Hello students, so in this video we will be solving the remaining questions from the topics matrices. So the next question says let A, B and C be three 2 by 2 matrices with the real entries, okay, such that B is equals to I plus A whole inverse and C is equals to and A plus C is equals to I. If B into C is equals to this and C into B is equals to this, then x1 plus x2. Okay, so finally we have to eliminate A, that is what we have understood first. Okay, we'll do one thing, we'll take this part. So B is equals to I plus A whole inverse. So we can do one thing, we will pre-multiply with I plus A. So we can say I plus A into B is equals to I plus A into I plus A whole inverse. So if I say this is x, x into x inverse is I. So we got one interesting relation that I plus A into B is equals to I. So similarly, can we say B into I plus A? Acha, let me write it down. Acha, this should also be I, right? So what can I say? I plus A into B is equals to B into I plus A, and that is equals to I, right? So I into B is B plus A into B is AB, B into I is B plus B into A is BA. So we said that AB is equals to BA, right? But we are not looking for a relation between A and B. I think we are looking a relation between B and C, right? Instead we want CB. So we'll do one thing, we will say A plus C is equals to I, right? Can we say C is equals to I? No, we will eliminate A, okay, because we don't want A, right? So we can we say A is equals to I minus C? Perfect. So if A is equals to I minus C into B, again B into I minus C. So here I into B is B minus CB is equals to B into I is B minus BC. So we can cancel this. I think ultimately we can say C into B is equals to BC. That's a wonderful result, I think. Yeah, I think the question is now solved, because CB is nothing but BC. So CB into x1 x2 is equals to 12 minus 6. So CB into x1 x2 is equals to 12 and minus 6. What is CB? CB is nothing but BC, that is 1 minus 5 minus 1 2. 1 minus 5 minus 1 2. Am I right? 1 minus 5 minus 1 2 into x1 x2 is equals to 12 minus 6. So we can say x1 minus 5 x2 is equals to 12. We can also say minus x1 plus 2x2 is equals to minus 6. I think we can comfortably add. So we get minus 3x2 is equals to 6. x2 will be equals to minus 2. So if x2 is minus 2, we can say x1 minus 5 into minus 2 is equals to 12. x1 plus 10 is equals to 12. x1 will be 2. What is he asking, dear students? He is asking us to find the value of x1 plus x2. I think it is 2 minus 2, that is 0. So 0 is the answer. Let us go to the next question. Next question says the number of 3 by 2 matrices A which can be formed using the elements of the set, okay, such that sum of all the diagonal elements of A transpose into A. So firstly we have to find A transpose into A, but A is not known. So we'll do one thing. Let us assume A as A1 B1 A2 B2 A3 B3. So what will A transpose into A be, dear students? It will be A transpose will be A1 A2 A3 B1 B2 B3 into A will be A1 B1 A2 B2 A3 B3. So what do we get here? I think so it is 2 cross 3 and this is 3 cross 2. So final result will be 2 cross 2. So what do we get here? We get A1 square plus A2 square plus A3 square, and this we are not interested in because we are just interested in the diagonal elements, sum of the diagonal elements. So here we get B1 square plus B2 square plus B3 square, and what is the sum of diagonal elements? That is equals to 5. Perfect. So I think we got an interesting result. So A1 square plus A2 square plus A3 square plus B1 square plus B2 square plus B3 square is equals to 5. Okay. Now this should be 5, okay, provided we use these elements. So the set contains minus 2, minus 1, 0, 1, 2. That means plus or minus 2, plus or minus 1 and 0. So how do we get 5? So we can say, see, one thing is minus 2 square plus 1 square plus 0 square plus 0 square plus 0 square plus 0 square is 5. So like that we can have multiple options, right? So let me write down the cases. Case 1 could be 4 plus 1, right? 4 plus 1. That means plus or minus 2 whole square plus or minus 1 whole square plus 0 square plus 0 square plus 0 square plus 0 square is 5. So how do we get this, dear students? So thoda bahut permutations and combinations recall kar lete hain. Bahut simple hai. So we have 6 options available. So from 6 we will select any one first. let us say A3 is selected. Let us say A3 is selected. Now A3 can be either 2 or -2. So we have two options for that. And now from the remaining 5, we will select one. Let us say B1 is selected now. Now B1 can either be 1 or -1. So again we have two options. Now once A3 and B1 are selected, remaining four, we will select them in 4C4 ways, and then we will arrange them in one way only, because all of them can take 0 only, right? They have only one option. It means A1 will take 0, A2 also will take 0. Next B2 will take 0, B3 will take 0. This is just an example, yeah, right? So what do we get? 6C1 is 6 into 2, 5C1 is 5 into 2, 4C4 is anyways 1. So we have 5 into 2 is 10, 10 into 2 is 20, 20 into 6 is 120. Perfect. So this is done. Now what about case 2, dear students? Case 2, do we have any other case possible? Firstly, 4 plus 1 is 5. Yeah, I think we can have this, right? That means, what does this mean? Plus or minus 1 whole square plus or minus 1 whole square plus or minus 1 whole square, right? Right. That means of the 6 options available to us, let us select any 5 first. Now each one of them can have plus or minus 1, right? That means each one of them will have two options, either 1 or 2, either 1 or minus 1. And the last one will have only one option, that is 0. So what do we get here? 6C5 is 6 into 2 to the power 5. So we have 6 into 32. So what do we get? 2, 6, 12, 6, 3 is 1, 6, 3 is 18, 18 plus 1 is 192. So any other option, any other case possible? 3 plus 2 should be 3 ones plus single 2. Not possible. I don't think any other case is possible. So I think this should be the answer. So required answer should be 120 plus 192. So we get a 9, 2 here. 9 plus 2 is 11. 1 plus 1 is 2. 2 plus 1 is 312. So 312 should be the answer, dear students. That's it. Thank you for watching this video. If you have any other method, kindly comment the methods in the comment section. Once again, thank you.